this is the awesome part. Because you guys are coming from different backgrounds, teach different subjects, there's some mix of elementary, high school, and middle school at a given table. Our goal is for you to actually just have fun doing the science and talking about this and sharing ideas with each other about the science, to be learners today, et cetera, et cetera. And we will start with the soda can and the bucket. We're going to be talking about student data also, by the way. We will then turn around and do more and more demos and keep going with this, and we have these simulations we want not in too long of a time. We want you to come up with a final version of what you think is happening here about the energy in this system. That's the focused question. What's going on with the energy in this system? And I want representations and pictures and not necessarily terribly many words. So this is not
and then
we want to erase some of the energy.
Oh yes, and then these are losing energy.
Radiant height alone. That's awesome.
Because it is losing heat. So we've got 1, 2, 3, 4, 5, 6, 7, 8 energy lines, 8 energy lines. This used to have, it's now got 6 energy lines, 8. Okay, 1, 2, 3, 4, 5. Okay. So,
So if there are lots of squiggles or less squiggles?
So we would say that this would continue to happen
yes.
until the squiggly lines were even throughout here and here.
These ones are too.
So maybe we
So
saw
eventually,
Yeah, and then we just, there's also, because the soda will still be like 5 molecules. This will go from solid to liquid, some of it.
yeah,
It
so
gets
some
warm
of
enough.
this, right? So you would have a phase change concentrated here. We let it sit long enough. It would even be because you're also having exchanges happening.
between that and the air.
But we want to know, but then again, we have to define our system. So
Yeah, I think
we
it's
want to not
soda
define our
and
system,
snow.
but we are still losing energy to the surrounding of the outside, the environment of the system, right? Of the outside of the system. Do we want to show some of the lost energy into the water with the color? Do you know what I'm saying?
Oh.
Instead of having these round, it would be purple.
So some of these would be have a green dot with a purple. Do you know what I'm saying? With like the purple energy lines showing that like the energy went from here to up here.
And then they are, like, energy is being exchanged back and forth
At an even rate.
Yep.
I like that.
because they're at equilibrium.
Yeah.
So we have a closed bucket. There's no air.
Yes.
No air.
No air.
We're saying that the air is not part of our system.
We're not taking into account the heat from room temperature air.
Gotcha. So that's what your green box is an isolating bucket and can, and that's it.
Yes.
Gotcha. Okay.
Is that okay?
We could.
Whatever you guys do.
Because we could do
So the wonderful trick is that you guys aren't answering this like other people are, and whatever you're doing is absolutely okay.
I suppose you wouldn't see as fast of energy transfers in the no air system, because it would take a really long time for the heat from the can of soda to move to the snow.
I think the initial transfer, because you have such a high concentration gradient, well, like what I would call concentration gradient between the two, so your initial transfer would actually be pretty quick. So like if I put the can in and pull it back out, the outside of the can is immediately pretty cold.
True.
But once you reach an equilibrium within the can, then you're going to start warming it back up a little bit, right?
All right.
So I would say that the initial transfer happens pretty quick, but then once you start nearing equilibrium, then your transfer of energy becomes a lot slower.
All right.
Because then it's within the soda and within the snow.
Yep. And it's not like
because as you lose energy, these molecules are moving slower and slower.
yes,
And so as that happens, you're having less collisions with the outside of the can,
yes.
and then therefore you're losing less energy. We gotta draw our little equilibrium.
Yep, because they're at the equilibrium.
Is the orange a representation that it came from the orange
Yes.
soda? That's
Yes.
the
energy transfers.
And then they're at equilibrium,
And they're what?
The transfer of energy is equal.
We're at equilibrium here,
Yeah.
and over here,
We're not.
you have and you have like their little movement lines.
Yeah.
So your solids have a lot less movement or smaller movement lines and you have much larger movement lines with
With the soda.
the soda, and
Gotcha.
you have a lot more energy. And then as they move over, it's transferring energy, like some of its energy lines over, so it has less energy lines around it.
So you have both the amount of movement and the amount of energy, like
Okay.
in the thing represented. So you're representing
Yes.
it two different ways.
Yes.
So, okay.